Hey, welcome back to POE. Today we're going to be talking about while loops and if-else structures. These right here are very important when it comes to programming the robots. Pay extra attention. We're going to spend quite a bit of time there with these while loops because whether it's the marble sorter or I can't think of another robot we're going to be making, um, this programming is very, very important. While loops. A while loop is a structure within a robot C that allows a section of code to be repeated as long as certain conditions remain true. So, what we're talking about here is where it says the condition. This would be where you'd be putting in some new information. We might be changing it here. It's not going to be condition. You're going to tell it while something is true. Um, the word while, then the condition, and the commands to be repeated. Um, Every while loop begins with the keyword while. You just simply type in the word while, and then this is again the condition part is what you're going to be changing. Um, Notice um, condition controls how long or how many times a while loop repeats. So you're going to say this right here is going to be um, it's going to be a set number equals some other thing. We're going to, and we'll go into detail about that. The condition is true, the while loop repeats. When the condition is false, the while loop ends, and the remainder of the program executes. Condition. Condition is checked once every time loop repeats before the command between the curly braces are run, and that's important. Commands between curly braces will repeat while condition is true. Program checks at the beginning of each pass through the loop. So what we're saying right here is you're going to be putting some type of commands in here between the brackets, and it's going to go through here, and you might have a counter up here or some other thing, but this is going to become a loop that starts to continuously happen here. And again, it's going to be if yes, it continues. If no, then stop. Kind of like our flowchart thinking was. Boolean logic, and that's what we kind of headed in here to. Statements that can only be true or false are called Boolean statements. Their true or false value is called a truth value. Um, Boolean logic, and this is kind of where it starts with um, condition. Remember earlier up here we were saying the condition. The condition. Well, if you look under the Boolean, here we're asking about the condition. One condition you might type in there is sensor value, and then tell it what sensor you're going to be dealing with. Are you dealing with the sonar sensor? Are you dealing with the potentiometer? Are you dealing with the bump switch? What we're saying here is this sensor is greater than 45. Is the value of the ultrasonic sensor greater than 45? Meaning, is it reading more than 45 centimeters away? True if the current value is more than 45, for example, it is 50. False if it's less than 45, for example, it's 40. Well, other conditions can be 1 equals 1. Ask yourself, is 1 equal to 1? True, it's always going to be equal to true. So if you put a condition in here of 1 equals 1, it's equal equals, what you're telling the computer is you want this loop to continuously run always. All right, that's the condition. It's just going to keep running this loop over and over and over again without any way of getting out of it until you turn it off. 0 equals 1 means that it would never work. All right, false. If it's false, I shouldn't say if it's never work, as long as it's false. All right, on here then, Boolean logic. This is important page here as well. Equal equal. I mean, this right here means is equal to. Examples of this would be 50 equals 50, or 50 equals 100. This would be false. 100 equals 50. That would be false. Um, the exclamation mark is not equal to. I don't know that we're going to use that a whole lot. You might come in time with that. But this is saying 50 is not equal to 50. Well, that's a false statement. 50 is not equal to 100. That's true. And 100 is not equal to 50. That's also true. So it's kind of like learning the language where you guys have all learned text language, and you know that LOL means laugh out loud. In When it comes to robot C, we have this different language where these symbols mean different things. Obviously, this should be an easy one. That's an is less than. This is an is less than or equal to. This is less than, or sorry, this is greater than, and this is greater than or equal to. All right, here's an example of writing a condition with a while loop. Here's our pseudocode up here at the top, and I've kind of highlighted that. While the bump switch is not pressed, wait until it's dark, then turn on light. Wait until it's light, then turn off light. So here's what's going to happen. While, and then we had to tell it what we wanted to do with here. What was our condition? The sensor value. Well, which sensor value? The bump switch, all right, is equal to 0. That means it's not being pressed. Because remember, the bump switch, when it's pressed, the bump switch actually will register a 1. Well, right now, when it's equal to 0, while it's not being pressed, here's what's going to happen. Until dark, meaning 500, the light sensor, they're telling it what to do, what they're going to use. All right. If that's true, then turn the flashlight on, full power. Until light, all right, 500, reading from the light sensor, turn the flashlight off. And what this is going to do now is this is going to be a continuous loop until you push it. Right, until you push it. Sometimes students like to use until statements. A while loop is much more flexible than an until statement. Here's an example. Down here it's going to start the motor. Left motor, and it's going to go full bore. The motor runs until an object is within 50 centimeters. Until sonar less than 50 centimeters. And they're telling it 50 centimeters is the distance and which sensor to look for. All right. All this until can do is tell it to stop. It can't turn anything else on. It can't turn anything else off because it only has this capability. An until statement is not exactly very flexible. Okay, what I want to point out to you is what they're saying down here. A while loop can do the same thing as what this until up here was doing. A while loop can do the same thing. Start the motor. All right, start the left motor. While the sensor value, the sonar, all right, they're telling which sensor is getting a reading of greater than or equal to 50. So the left motor is going to keep running, all right, until, all right, or while the sensor value is greater than or equal to 50. As soon as it gets to 50 or less, it's going to stop the motor, all right. Here's why the while is nice. We can change the last part here. All right, we can expand the condition here. And then also we can put things in the middle here. We can be telling this that if this happens to become greater than or equal to 50, then we can tell it to kick these other things off. Maybe we're going to turn the flashlight on. Maybe we're going to move a servo to a different spot to maybe put out a bumper. All different types of things can happen with this while loop. Now they're really just trying to expand this and show you how you could add on to this. What I want you to see down here is here in the middle with this while loop, again, we're talking about, you don't have to really write any of this down. I just want you to notice that they're typing in start the motor and the sensor value. Again, every time they say sensor value, they're telling it what sensor. In this case, it was potentiometer. All right, potentiometer. And there's a lot of other things that we could have here. But what I want you to see is after the sensor value, here they had sonar, sensor value had potentiometer. We could put bump switch, whatever sensor value we're going to be using. Okay, here's the last thing I'm going to talk about today, and that's a timer. Timers are on a loop control where would the wait statement go if we wanted the loop to repeat for a controlled amount of time? Nowhere. We need something else. Well, the solution is timers. Internal stopwatches. There's going to be 4 available. They're like encoders. Timers should be cleared before they are used. Be careful, don't clear a timer in a timed loop. Okay, in this, timer 1 is used as the condition for the while loop, which means that this is going to keep repeating. Basically, they're going to clear timer 1 is what this first one says, and then it says while less than 30 seconds have elapsed, it's going to keep running this loop. All right, for this 30 seconds is how long we want this loop to run. Now this shows 30,000, but basically you can get rid of the last three zeros when you're looking at this. And let me put this in black. And this really, all right, is 30 seconds. All right, these last three zeros go down to tenths, hundredths, thousandths of a second. So if sensor value, the bumper is at 1. All right, the bumper, that's the bumper switch. If that was at 1, what would happen is it would start the right motor at about half speed. If, all right, sensor value, the limit switch is at 1. If we've clicked on the limit switch instead of the bumper switch, then it's going to start the right motor, and it's going to go in reverse at half speed. Else, all right, now we have another statement in here, stop motor, and they're telling it which motor to stop. Well, what I really do not care about this bottom part here right now, just as of yet, because we're going to get into ifs and elses tomorrow. What I want you to understand is that the timer, all right, again, this programming right up here can be used in a while statement as well. All right, this part up here can be the loop that we use so that something will continuously happen. You'd want to say clear timer, tell it which timer. You have timer 1, timer 2, timer 3, timer 4. And then while the timer 1 is running, and it's less than 30 seconds, we're going to keep running this loop. After 30 seconds, the loop stops. Well, hey, I hope that was beneficial. I'll catch you on the flip side.